All right, so today we are going to start our next topic, which is logarithms. Okay, this is the next thing that we have to do. We have covered four topics by now, which were which are all actually classified, which all are classified as algebra in your A-level math syllabus: modulus inequalities, polynomials, binomial expansion, and partial fractions. These are the topics that we have done until now. Now, today, what we're going to do is we are going to start with our next topic, which is logs. This is a topic that's actually uh, one that a lot of people find confusing for some reason. So you need to really make sure that you're paying attention and you understand the basics well, because it's a relatively uh, easier topic in the sense that the questions that you get in this, they do not really require a lot of thinking. Once you know the properties of logs and the laws of logarithms well, you can actually just figure out all questions quite easily if you develop a proper understanding of this. So let's start with it then, and let's try to understand what this is all about. Now, logarithms are actually very closely related to indices. Okay, so before I actually start with this, I want to make sure that you understand the different indices rules that you used to have. Okay, so let me just remind you about some of those first of all, indices rules, because you're going to need them when you use logarithms as well. All right. First of all, remember that rule. If you got something like this, a raised to power x plus y, you can actually write it in this form. Okay, so let's start with these indices rules. First of all, if you have something in this form, a raised to power x plus y, what you can do is you can break it down into two parts and write it like this. You can say this is a raised to power x multiplied by a raised to power y. Now uh, you're more used to using this the other way around, and you have the form on the right given, and you want to convert it to the form that is on the left, right? But this is what you're going to be using a lot more commonly in this topic, going the other way around. If you have something in this form, a raised to power x plus y, how you can break it down into two parts like this? It becomes a raised to power x into a raised to power y. If the bases are the same, then the powers get added, right? That's what to remember. But if the powers are added here, you can actually separate the bases like this, so it becomes something like this. All right. So that's the first rule that you need to remind yourselves about. Then there was another one that was very similar to this. When you have a raised to power x minus y, this can be written as a raised to power x over a raised to power y. You can actually split it like this. All right. Again, you're more used to using this the other way around. If you have this thing given, a raised to power x over a raised to power y, that can be written like this: a raised to power x minus y, but you'll need to use this from left to right here a lot more commonly. So keep that in mind. If you have a power like this on something, you can break that power into two parts like this. A raised to power x minus y, that can be written as a raised to power x over a raised to power y. All right. Now, similarly, there's another rule that you have. If you have something in this form, a raised to power x into b raised to power x. So there are two numbers or two expressions multiplied and they have the same power. This can be written as a into b whole raised to power x, and also the other way around. If you have something in this form, AB whole raised to power x, you could write it the other way around so that it becomes A power x and B power x. You can split it like this. But remember, it doesn't work like this for when you have addition. So if you have, for instance, A raised to power x plus B raised to power x, please remember this is not the same as A plus B whole raised to power x. It's not the same, right? So you need to expand this using a proper identity, not just split the powers like this. You can do that when you have multiplication, okay, but not when you have addition. It doesn't work for addition like this. All right. Similarly, you have another index tool. If you have A raised to power x over B raised to power x, it can be written as A over B whole raised to power x. Again, it works both ways. If you have the form on the right side, it can also be converted to this form on the left side. So it works both ways. All right. So these are some rules that you need to remember from your O-levels. There's one more that's really important. If you have A raised to power x whole raised to power y, that becomes A raised to power x into y. And it also works the other way around. If you have something like this written, you can write it in this form, A raised to power x whole raised to power y. How is that going to work? For example, sometimes you'll have something like this given, 2 raised to power 3x, for instance. There are two ways of applying this rule here. You could either say it's 2 raised to power 3 whole raised to power x. And what does that give you? That gives you 8 raised to power x. That's one way of using this rule. Another way, which is going to be more useful and required in some cases, is that you have 2 raised to power x inside, and then outside you have 3. And that comes from this rule. If you've got the powers multiplied like this, if you've got something multiplied in the power like this, you can have some part of it inside the bracket and some part of it outside the bracket. And you'll need to use this, so it's 2 raised to power x whole raised to power 3, like this. You'll need to use this a lot when solving equations where you would require to use some kind of substitution. We'll require to use some kind of substitution. Okay. So these are some indices rules that you should keep in mind, which are going to be helpful when you use logarithms. Okay. Now, and some other examples of this could be if you have 5 raised to power x plus 2 sometime, this can be written as 5 raised to power x into 5 raised to power 2. Okay. If you have 4 raised to power 2x plus 1, you could split it as 4 raised to power 2x into 4 raised to power 1. And then if needed, you could also write it like this, 4 raised to power x whole squared into 4. So depending on what the context requires, you can do all of this manipulation with indices. So this is something that you need to be familiar with. Okay, so all of these indices rules, they are going to be important. Now, why are we talking about indices here? This is a logarithm topic. Where do indices come from? Indices are actually very closely related to logs. Let's try to understand how, and let's try to understand where logs come from in the first place. Let's start with an example. Let's say we've got 4 raised to power 3 equals 64. All of you are familiar with this representation where you have something in power, 4 raised to power 3, that equals 64. This is the power notation, the index notation. All of you know how to use this, right? This same thing can actually be written in terms of logs as well. And how is that going to work? This can be written like this, log of 64 base 3, base 4 in this case, not 3, base 4 equals 3. You've got the same 3 numbers. 4, that's coming here. And you have 3, that 3 has gone here, and 64, that 64 has come here. Those same 3 numbers can be connected using logs as well. So what exactly does this form mean? The left-hand side that you've got here, this basically means what power of this number, that's 4, is equal to 64. That's what this notation means. So you've got 2 numbers with logs. With the log, you've got one number here. That is the number on which log is being applied. And this 4 is actually called the base of the log. How you understand this statement is, what power of 4 is going to give you 64? So what power of 4 gives you 64? 3. So the result of this thing is actually equal to 3. All right. So that is what this log notation actually means. Okay, I think there's still some lag, but let me just try and see how it goes. Okay, so we were talking about this. If we have something like this written, log of 64 with base 4, this is how we read it. We're taking log of the number 64, and the base is 64. All right. What we're doing is, whenever we have something like this, log of b, or let's say log of a with base b, what this means is what power of b is equal to a. That is what this notation is going to mean. Log of a with base b. What this means is what power of b is equal to a. All right. So for instance, if you write this in index terms, and if you know you've got something like this, log of a with base b is equal to, let's say, a number c. How can you write the same thing in index form? You would say the left side means what power of b is going to give us a. This thing equals c. That means b raised to power c should give us the number a. So whenever you've got something in log form like this, log of a with base b equal to c, you can convert it to the index form such that it becomes a equals b raised to power c. That's the connection between the log form and the index form. So this is how you're actually going to do it. Whatever is the base of the log here, you're going to take that to the other side and make it the base of this number c. So it's a equals b raised to power c. Okay. So this was the base of log. It goes to the other side and becomes the base of c. This is the first thing that you need to know about logs. This is how the log thing is defined. How you convert from the log form to the index form. Now, let's take an example. If you've got something like this, log of 125 with base 5. Now, what power of 5 gives you 125? Power 3. This thing can be written in power form like this. This 5 is going to go to the other side, become the base of 3. Right? The base here goes to the other side, becomes the base of 3. And you have 125 equal to 5 raised to power 3. This is how that log form can be converted to this index form. Does that make sense to everyone?
Yes, sir.
Does this convert? Okay. This is how we can go from the log form to the index form. Now, once you understand what this notation means, let's think about the values of these logs. Log of 5 with base 5. What would that be equal to? So you're asking yourself, what power of 5 is going to give you 5? Well, power 1, that is going to give you 5, right? Similarly, if you have log of 7 with base 7, what power of 7 gives you 7? 1 again. You get a general rule from this, and that looks like this. If you have log of A with base A, this is always equal to 1. Okay, log of something with the same base, that equals 1. Why? Because you're asking yourself, what power of A is going to give you A? Power 1. So this equals 1. All right, so if the number here and the base of log, if they're both equal, this thing equals 1. All right, so this is the first rule. This is the second rule that you need to know about now. First of all, how do you convert from log to index form? This is the conversion rule that we've got. If you have log of A with base B, that equals C. If you want to convert it to index form, you take this base of log to the other side and make it the base of C. And that gives you this. All right. And this is the second thing now. If the number that you're taking the log of and the base of the log, if they're both the same, then that thing equals 1. Let's think about another thing. Let's say we've got something like this. Log of 1 with base, let's say, 6. What would that be equal to? What power of 6 is going to give you 1? Well, 6 raised to power 0, that should give you 1. So this number, therefore, equals 0. Log of 1 with base 6 equals 0. Let's try another base. Let's say you have log of 1 with base 8. What about that? What power of 8 gives you 1? Well, 8 raised to power 0 is going to give you 1. So this also results in 0. From this, you have another general rule for logarithms, and that looks like this. Log of 1, no matter what the base is, let's the base is 0. Okay? So we had 6 base earlier. 6 power 1 gives us, 6 power 0 gives us 1. If you have 8 base, again, 8 power 0 gives us 1. So any number raised to power 0, since that is equal to 1, whatever the base is here, log of 1 is going to result in 0. Okay? So if both numbers are the same, if you've got A here and also A here, that results in 1. And if this number is 1, log of 1 turns out to be 0, no matter what the base is. All right? But there's some exceptions to these rules. Like for many rules, we have some exceptions, and they look like this. If you write something like this, log of 5 with base 1. Let's start with this example first. What would that be equal to? Any guesses? Log of 5 with base 1? What should that give us? Log of 5 with base 1. So what question are we asking ourselves? What power of 1 should give us 5? Yeah, so we are asking ourselves, what power of 1 should give us 5? Well, there is no such value, right? No power of 1 can give us 5. So this is actually undefined. You don't have any value for this. This thing is undefined, okay? This thing is undefined. There's no value for this. But now, what if you had log of 1 with base 1? What about this? Remember the rules that we discussed earlier? We said if both numbers are the same, this should be 1. Now we've got both numbers same, so we might think it's 1. But we also said log of 1 is 0. From that rule, it should be 0, right? But think of it logically. What power of 1 gives us 1? It could be any number, right? 1 raised to power anything is going to be 1. So you could have any number as an answer to this. You could have, 3, you could have 10, you could have 20. There are infinitely many possible answers for this. So there's no one single definition for this. There's no one single definition. So again, for that reason, we say this is also undefined because there's no single definition for this. It's undefined. Okay. Let's take another condition. If you try something like this, log of -4 with base 2. Now, what power of 2 is going to give us -4? Well, there's no power of 2 that is going to give you -4. Okay. So that is also undefined. Because any power of a positive number cannot give you a negative number as the result. This thing is also going to be undefined. Log of -3 of, let's say, -20, or let's say -9, let's say. We again have a problem. -3 raised to power anything is not going to give us -9. In fact, powers of -3, powers of negative numbers are kind of always, they don't always give us value. So if you were to try different numbers, -3 raised to power 1, that will give you a result. -3 raised to power 2 will give you a result. -3 raised to power any integer is going to give you, try decimal powers of negative numbers, like 1.73, right? And then try, for instance, random decimals, 2.578. You'll find out they are not always defined. Powers of negatives, you can't have any power of a negative number. There are some that are defined, but there are some that are not defined. Now, because of all of this, there are some conditions that we have for the numbers that can come with logs. There are some conditions that we have for the numbers that can come with logs. And what that means is, if you have log of a with base b, if you've got something like this, you have some conditions for a and b. This number a here has to be a positive number. This number a has to be a positive number. If it's anything that's not positive, log is going to be undefined. This is a very important condition. And that basically means you can never have a negative number inside the log. All right, log cannot be applied on negative numbers, and also not on zeros, because if you had, for instance, log of 0 with base 2, you're asking yourself, what power of 2 is going to give you 0? Well, there's no such power. So log of 0 is also undefined. So the number that you can have here in place of a, it has to be a positive number. All right. Otherwise, your log is going to be undefined. Okay. So that's why I was showing all of these examples to you. If you take a log of negative number, it's not going to be defined. All right. There's another condition. The base that you've got here, that should also be positive. And there's another condition for that it cannot be 1. So there are two conditions. The base cannot be base has to be positive, and even among positive numbers, it cannot be 1 because 1 causes these problems. If you have 1 as the base, 1 power anything is always 1. So log with base 1 is not defined for that reason. And since negative numbers do not have all of their powers defined, that is why this base can also not be negative. All right. So these are some conditions that you need to know of. So now that we discussed the reason for that, this is something that you have to remember. Now, this first one is going to be more important, that you can only have positive numbers inside the log. You should also know this condition for base, but all the logs that you will come across in your syllabus will always have a positive base already, which will not be 1. So you won't have to think about this that much, but this is going to be very important. The first condition, that you cannot have a negative number inside the log here. The base condition will always be met already in the question. So you don't have to worry about that condition. But this condition is going to be important, that the number that you take the log of, that number should be positive. So even if you try this on your calculator, try taking log of a negative number, try taking log of 0, that is always going to give you an error. So this number should always be positive. All right. Now let me quickly revise what we've done until now. We've talked about how we can go from the log form to the power form. The base that you got for the log, it goes to the other side. It becomes the base of the number on the right side. Log of something with the same base, this results in 1. Log of 1 results in 0. And then we've got these conditions for the numbers that can come with log. This is the important condition, that you cannot take log of negative numbers. You can write that in words as well, because you'll need to use this again and again. Log of negative numbers is undefined. Log of negative numbers is undefined. You can't do that. All right. Okay. So now that we understand these basics of logs, there are 2 specific types of logs which are used very commonly. And you'll find those logs in your calculator as well. They're separately mentioned. And those 2 logs are one that has a base of 10. We call these common logarithms, common logs. One of them is log with base 10. We also write it as LG in short form. Okay, and in your calculator, it's just written as log. So when it just says log without any base, you can assume that the base is 10 in that case. All right. Now, this is something that is actually used very commonly in practice. Now, since it's used very commonly, what they do is they write it in a short form like this. So you don't have to write this base here again and again, right? So you don't want to write the base again and again. For that, you have this short form for this. That's LG. Okay, so you might see this being used in some cases, but the more important one for us is the second type of log, and that is a log that has base E with it. This is another common logarithm that you need to know about. Now, what is E? It's the base of this log, and it's actually a specific number. Just like pi, remember pi is 3.1415 something, right? E is also a number. It has a specific value. It's a constant, 2.71828, and so on. And it's a number that is actually found in nature a lot for some reason. So those of you who study physics, you'll see this very often in different formulas as well, because it's found in nature very frequently at different places. They find some ratios being equal to E for some reason. This is what the number is, 2.71828. And because of its relationship with nature, this specific log that has a base E with it is written as ln in short form. ln. ln means a log that has base E. Where does ln come from? This stands for natural log, right? N is for natural and L for log. So this is natural log. So this is another common type of log that you need to be familiar with. This is more important than the first one because you can do everything using the second one. You won't have to use the first one. This is going to be required to know what ln means. ln is a log that has base E with it. All right. So now if you had to evaluate ln of E, for instance, what would that be? ln is the same thing as log of E, log with base E, right? So ln E could be written as log of E with base E. So instead of ln, we could write log with base E. That's what it stands for, right? It's just a short way of writing log with base E. This is the short form for log with base E. So if you have ln of E written, that means log of E with base E. What does that result in? This is equal to 1. So if you use that button on your calculator, the ln button, ln and then have E after that, you'll see that results in 1. Okay, because E power 1 is going to give you E. So that's the value that we've got for ln of E. All right. Now, if you were to try this, ln of 1, for instance, what is this result in? ln of 1 equals 0. Just like any other log, if you take log of 1 with base E, E power 0 is going to give you 1. So ln of 1 results in 0 for that reason. Okay, so this is a common type of log that is used very frequently. You'll find this again and again, coming up again and again, not just in this topic. It'll come in differentiation and integration in a lot of different places later on. Okay, so keep this in mind. ln, what does it mean? It's a short form of log with base E, right? E is a number. That's this number. It has a separate button on your calculator as well. You'll find that, I think, on top of the ln button. If you look at the top, it will be a button like this or somewhere close there. All right, so this is a number that you have. That's the base of this log. This log is called ln. All right, so you need to be familiar with this. Two things in particular. ln of E equals 1 and ln of 1 equals 0. All right. Now, these were some basics of logs. Now, the next thing that we want to do is we want to understand some common laws that we have for logs. Okay, so just like indices, where we have these rules, we have some rules for logs as well. And they come from these rules for indices. They're derived from these rules. One is called multiplication law, then you have a division law, and you have a power law. Okay. Tomorrow, we will be discussing those 3 laws, and we will then use them to solve a number of different types of equations that you could not solve without knowing logs. All right. So in our next class, we'll be covering those laws of logarithms, and using those laws, we will learn how to solve a number of different types of equations. So tomorrow's class is going to be really important because we'll be covering all the different types of equations that you end up getting in the exam, and we'll learn how to solve all of those equations. Okay, so if you understand tomorrow's class, then the logs topics is pretty much done. We will spend another session on doing practice questions, and you should feel comfortable after that.